I wanted to follow up part 5 with an addition to what we're doing. So in the previous video, we used the numerical integration tools in Mathcad to calculate what this double integral would be and solve this particular problem. Let me add a little nuance here. Let me, instead of writing this as a solution to the particular problem, let's rewrite this delta sigma as a function. So I could call it sigma sub z or something like that. Yeah, let's go ahead and do that. Sigma, control G, parentheses, and then z, and then hit shift semicolon. And let me just copy all this stuff into the new function that I've got. Okay. Now I need to tell Mathcad. Let me go ahead and take it down a little bit. I need to tell Mathcad what the limits of my function are. So, and I've kind of done this down here. Let me reproduce this so you can see how I did it. So I'm going to vary z. So I'm going to set some ranges for z over which I want to calculate this at. So I'm going to start at 0 meters, comma, and then let's say 0.1 meters, and then let's type in, say, 50 meters. Okay, so now I've given Mathcad a range over which I want to calculate this function. And let me just do a quick plot here. Let's just hit Control 2. And you can see it throws up a quick plot. So my y is going to be sigma s control G comma x. I'm sorry, z. That would have been an error. And my units are kPa. And then I'm going to give it my x units, x value, which will be z. And then my units is meters. And I should get some sort of function here, and I do. So let me move this over where it should be so you can see it. So what this does is that this shows how the pressure varies the further I get in depth. So z is my depth axis. You know, let me just play around this. Let's see if I can get it to where it looks better. Let's, instead of having this as z, let's have sigma as z. Let's have this as negative z. Let's say negative z. Well, that'll probably screw my. Let's start out with z and change this to meters. And let's put my functional form down here. Sigma z, and then this will be in kilopascals. Let's see if that works. I'm just thinking about it. Yeah, so that looks a little bit better. So if I wanted to, well, what happens if I gave that a negative? Oh yeah. So this is pretty nifty here. So what it's saying is that at right below the foundation, the pressure of the soil should be basically what it is in the foundation, should be 50 kilopascals. But as I go deeper with depth, you can see that it drops off very quickly until I get to some point where it becomes asymptotic to almost 0. So if I wanted to change this, let me change this from instead of 50 to 30. Just going to think about it for a minute. Okay, you can see how it changes. So if somebody was going to say, okay, I need to put a pipe underneath this structure, and the allowable pressure on the pipe is, I don't know, 5 kilopascals, how deep does it have to go beneath the building in order for that not to be exceeded? Well, something like this would tell you. So instead of having to go through a bunch of iterations, if you were doing this in Excel, where you had to reevaluate it at each of the points, and then you had to graph those points and then draw a line, Mathcad just makes it very easy for you to do that. You saw how long it took me. It just takes a minute or so to actually graph this thing. and that way you can look at some of the answers, and then you can play around with it. Let's say if it was 20 feet instead, then you can, again, you can make this look however you want to. You can change the XY scale on it. Again, if you wanted to put it in as a chart object, you could, and put grid lines and all kind of stuff in that. But that's just again, just take something that would take a while to program in Excel. You can put it in very quickly in Mathcad, and you don't have to spend hours or days debugging the thing because it's pretty obvious that it's giving you a reasonable answer. So that's how you can enhance what we did with the numerical calculation by instead of evaluating the integral at one point, you can have Mathcad evaluate it at a bunch of integrals. Let me change this just a little bit. So if I change this range, this tells Mathcad is that I'm going to start at 0 and I'm going to go to 20, and I want you to calculate this in increments of 1 meter. Okay, you can see how it starts to get not very a smooth curve. If I change that to 2, it should make yeah, you can see it's starting to really get kind of discontinuous. So you're trading off speed of calculation with how nice the graph looks. So if I put a decimal point there, it should look a lot smoother, and it does. So if I go back to the 1/10 of a meter, then that looks even smoother. So what Mathcad is doing is that it's calculating the change in pressure at 0 meters, 0.1, 0.2, 0.3, etc., all the way up to 20, and then it graphs that for you automatically. Let's change this to, say, 30 meters. And you can see I mean, it takes a few milliseconds to actually run the calculations, and there are some things you can do in Mathcad that can take a while. But generally, you can get something calculated fairly quickly and easily. And again, you can make this all pretty and put it in a presentation or a report, and really get some mileage out of the capacity of Mathcad.